Dear students, today we will discuss sign convention for lenses. This is which lens? Convex lens, correct? This is concave lens, very good. So in this case, what will be U? U is always negative. What about the V? That will be positive or negative? Let us see. We will discuss the rules of sign convention for lenses. So the first rule is same as that of the spherical mirrors. That is, all distances are to be measured from the optical center of the lens. Yani center of the lens, yani optical center of the lens. In case of the mirror, it was the pole of the mirror. So all distances are to be measured from optical center of the lens, that is O. So this is clear. The second rule is again the same as case of the spherical. All distances along the incident ray will be taken positive, and in the opposite direction to that will be taken negative. So in this case, this is the V. So V means OA dash. So when you B over O and then you move to measure this distance V, then you will move this way, and the incident light is also coming in the same way. And where from the incident light comes always? It comes always from the object. That is a very, very important point. So here the V is positive and here it is U is negative. In this case, again, the incident ray is this from the object and the U is this, so it is negative, and this time the V is also in this direction, so it is also negative. So in case of concave lens, U as well as V is negative. So second case is all distances along incident ray or light are taken as positive, or vice versa. Vice versa means in the opposite direction, of incident light or ray, distances are considered negative. So first rule is all distances are to be measured from the optical center of the lens. Second is all the distances measured along the direction of incident light are to be taken positive, and in the opposite direction they are to be considered as negative. And the third is the same as that of the spherical mirror. Heights above the principal axis. Heights above the principal axis are considered positive, and below it to be taken as negative. So in this case, AB, in the first case, This suppose I call it A and this I call it B. So in this A, AB is positive and A dash, B dash is negative. In second case, AB is positive and A dash, B dash is also positive because this is above the principal axis, so it is also taken as positive. And the fourth rule, which is very important, rule in the sense you can make it, कि light is always to be taken from the object. Yani light comes from the object. So light always considered to be originating from the object. Originating or coming, you can say, coming from the object. So this should be the first one you can say, or this is to be noted very well, that light will be always coming from the source. Source means object. Secondly, when you are going to measure the distance, first of all you have to be at the optical center and then you have to move where you wish to measure the distances. If you want to measure the distance of the object, so you have to move from this to this. So this is your direction and the incident is in this direction. So that will definitely is negative, and that is why U is always negative, because always light will come from the object to the lens and you have to move from lens to the object. So it will always be in the opposite direction, so it has to be taken as always negative. So here the distance V, for measuring V, you have to first come on the optical center, then you have to move towards the image. So you are moving this way and the incident then light is also coming in the same way. So that is also, that becomes the positive. In this case, U is same way, you have to be from optical center to object. So you are moving this way and incident light is moving this way. So it is negative. And to find out the image distance, again you have to be at O, yani optical center, and then you have to move towards the image. So you are moving this way and the incident light is moving this way. So it is in opposite direction. That's why it has to be negative. And the height, I have told you, it is positive, AB is positive, A dash, B dash here, it is below the principal axis, so it is negative. In this case, it is above, positive, it is again above, and it is positive. We can just take one more example of convex lens. Just we can see when object is placed between optical center and focus. So if the object is placed like this, so this will be moving this way, like incident ray is like this, and the focus is here. So the ray will move this way, and then you have to just take it this way. So the image is formed here. This is A dash, B dash, this is A, B. This is the ray. So they won't meet. So they will meet, or they will appear to meet somewhere here. So here U is negative. Here also V is negative, because you have to move from O to B as well as O to B dash to measure the distance of the image. And here AB is positive. So is the A dash, B dash, because it is again on the above side, above the principal axis, upper side you can say. So these are the situations in case of convex lens. This is the only situation where this is positive, image distance is positive. So you can just revise. Light is to be considered originating from the object always. To measure distance, you have to move from the optical center of the lens, and you can go toward the object as well as toward the image. So see, if you are moving along the direction of the incident light, then it is to be taken considered as positive, and if you are moving opposite to the incident light, then it is to be taken as negative. And that is why U is always negative, because light is coming, incidental light is coming from object to lens, and you are moving from lens to object, so this will always be in the opposite direction, so U is always negative, and other image distances will be accordingly. You have to follow this rule. So heights above the principal axis are taken positive, heights below the level principal axis are taken to be negative. Thank you.